Yeah, in this video, we are going to see about the armature winding of an alternator. So there are three types of armature windings will be used. One we can call it a general armature winding, can be classified as single layer and double layer winding, and second full pitch and short pitch winding. Third one is concentrated and distributed windings. So we will see one by one. Single layer and double layer. You just see here there are two figures A and B. A is a single layer and B is the double layer. The slot, you can notice a single slot is there. In this slot, the only one conductor is placed. So this we call it as a single layer. That means each slot has only one coil side or one conductor, one coil side. Then we call it as a single layer. And double layer, you can notice down there are two coil sides are here. So in the same slot, in single slot, there are two coil sides are placed. Each slot has two coil sides. Then we can call it as a double layer windings. Next, full pitch and short pitch. First we will see about full pitch. If the coil in one slot is connected to one pole pitch, that means 180 degree apart electrically, one pole pitch distance away from the coil side of the another slot, then we call it as a full pitch. Simply we can call it as the distance on a periphery, the armature periphery, between the two coils, one coil and the other coil, that means starting coil and the ending coil, is n slot. N slot is nothing but a number of slots per pole. If it is an 18 slots of the total armature, if a two poles are there, 18 divided by 2 we call it as 9. So the n will be 9. So the 9 slots will be there. Or otherwise 180 degree, then the coil can be called full pitch. That means the distance of a periphery of an armature between the two coils is n slot or 180 degree, then the coil is called full pitch. So you can see here the slot 1 and slot n plus 1. So this n is nothing but a slots per pole. So the conductor is starting at the slot 1 and ending at the n plus 1. So this we call it as a full pitch. The electrical angle between the two slots is nothing but 180 degree. The next one, short pitch. If the coil is less than one pole pitch, that is less than 180 degree, then we can call it as a short pitch, and also we can call it as a fractional pitch coils. Okay, so you just see here this slot 1 is not connected n plus 1. So let us in the same example, the armature has 18 slots. There are two poles, so each poles have 9 slots. So if it is a full pitch, the slot 1 should have a starting conductor and the ending conductor should be at the slot 10. That is, we can call it as a full pitch. But it is not like that in this case. So it is less than the 180 degree electrical degree or less than the n values. So the coil span less than 180 degree, that means the slot number 1 is connected, that means ending at the slot number 9, or it can be end at the slot number 8. Then we can call it as a short pitch. That is a short by one slot. That is why we call it as a short pitch. When we go for the short pitch, there are n number of advantages. For example, the first one is the length of coil is less, because let us assume the length of coil will be one short, so that is less than the coils will impact in the less copper conductors. So this will be very economical. So using the less number of copper will be an economical solution. And also the short pitching eliminates high frequency harmonics. So usually the high frequency harmonics distorts the sinusoidal waveform. So we can obtain the more sinusoidal waveform due to the short pitching, so that the quality waveform can be ensured. And as the high frequency harmonics is eliminating when I use the short pitch, so that the eddy current and the hysteresis losses, that is influenced by the frequency, that is depends on the frequency, can also be reduced here. And so overall the losses are less, and eddy current and hysteresis losses there, so that the efficiency can be improved. Next one we can see it concentrated and distributed winding. The concentrated winding, all the conductors or all the coils belong to the phase. If it is a three phase, all the concentrated winding, in concentrated winding, all the conductors or the coil belongs to a phase, are placed in one slot. That means only one slot under every pole, then we call it as a concentrated. But in case of distributed, the conductors are distributed among m slots per phase per pole. So every pole will be having the different slots. The coils will be placed distributively, that means equally. So then we call it as a distributed winding. So we can see one simple example. In three-phase alternator, we have seen there are three different sets of windings, each of phase. So depending upon the total number of slots and the number of poles, we have some certain slots per phase that is available for the each pole, right? So this we can call it as m. M is nothing but a slot per pole per phase, that is equal to n divided by number of phases. So if the total number of slots 18, n will be, and the poles will be 2, so n will be 9 and m will be 18 divided by 2 divided by 3, so it's nothing but a n equal to 9. Sorry, n equal to 9 and m equal to 3. So we have 3 slots per pole per phase available. So now n number of poles per phase are placed under